Hi, and thank you for tuning into this edition of Tech Corner. My name is Fabian and I'm Accumulator responsible for Revolve NTNU Team 2018. Today, Jonathan, Adrian and myself are going to talk about our in-house developed Accumulator and Accumulator management system. In many ways, the high voltage battery can be seen as the heart of the car, supplying the inverters with DC electric power. There it is transformed into three-phase AC power, which the motors can utilize. The high voltage battery is built up by lithium polymer cells, just like this one. Every battery has around 4.2 volts when fully charged and a total energy of around 24 watt hours. This cell can also discharge around 100 amps for short bursts, so you could say it's quite explosive. So how do we combine these cells in the high voltage battery? To get the power, current, energy and voltage we want, we this year have designed the battery package with two parallels, each containing 140 cells. This gives a total of 280 cells. This is a drawing of the battery package seen from above. As you can see, there is a long series circuit through the 7 segments I talked about, and between these 2 points you have a potential difference of around 600 volts. Let's take a closer look at one segment. As you can see, every segment has a total of 6 PCBs. The PCBs that are located right above the cells, this one, we have called the high current printed circuit board. This PCB works as the high current path through the battery package. So, as you can imagine, these copper layers are a bit thicker than ordinary PCBs. So the current goes like this through the battery package. This PCB has one more function, to measure the temperatures and voltages of every cell pair in the battery. The readings of the cell voltages and temperatures goes into this connector, which connects the high current printed circuit board with another PCB that Jonathan will talk about now.
Thank you, Fabian. Hi, I'm Jonathan and I'm responsible for making the slaves, or monitoring circuits as we call them. They're called slaves because they do not have a smart main chip themselves. Instead, they got all their instructions from the master controller. I decided to make 2 types, slave A and slave B, one for each orientation on the high current PCB. The slaves gets its power from the very module it sits on, converting some of the battery power to usable power for the local chip. The signal then gets looped through the high current PCB, measuring each and every cell individually, making mapping of the battery extremely convenient later on. This really helps when we want to know if the battery outputs wrong voltage or the battery overheats during summer. One of the most important aspects of the slaves is the ability to balance the pack. This can take a long time, and the slave will make sure that all of the cells behave as they should. The concept of balancing is when you apply a voltage over the cells so to even out the cell's natural tendency to drift over time. When all of the information is gathered, it is sent over to the master controller board using the serial communication SPI. Even though the slaves themselves do not hold any software, they are responsible for monitoring some key aspects of the battery, making the battery safer to operate. The master then decides what to do with the information, and the monitoring is now done.
Thank you, Jonathan. Now, my name is Adrian and I will now talk to you about the Accumulator Management System Master Controller. As you can see, it's quite large. It's one of the largest and most complex PCBs on the entire car, and it has a lot of functionality. Now, the essentials are the power supply, the USB connectivity and the microcontroller unit. We also have a controller area network for communication with the rest of the electrical system, and ISO SPI for slave communication. Most of the functionality is specified by the rules, like the accumulator current measurement, the insulation monitoring device, and the ability to open the shutdown circuit. Some functionality is more nice to have than need to have, like the high voltage measurement. When designing the PCBs, we use Altium Designer and excellent software for making detailed schematics and PCB design and layout. The highest priority for me this year has been to make a reliable and accurate high voltage measurement system which measures the voltage outside the airs. This will benefit both the state of charge and the torque vectoring, which will help the performance of the car. I will now give you a very basic demonstration of how it works. Right, now I have connected the master controller to a 24 volt power supply. I have communication over CAN, and I'm now applying about 45 volts on the high voltage measurement circuit. And I'm now using Revolve Analyze, which is our in-house developed software for testing and data acquisition, to get the CAN messages with the measurements. And as you can see on this graph, it is now displaying the voltage, and which I now am increasing up to about 85 volts. So yeah, this is basically how it works in the car. Obviously we will have a bit high voltage up to 600, but yeah, it's a basic demonstration of how the system works. So that was a short introduction to our system. Thanks for watching, and we hope to see you during the summer. Goodbye.